These notes are from Chapter 7 or Chapter 12 of the new edition of our Research Methods book. And it's in regards to the selection of research participants and also called sampling procedures. So the selection of participants is really important, especially if one is doing more social or behavioral research. And so there are three basic questions to consider. One is, are the research participants appropriate for the research question? A second important question is, are the research participants representative of the population of interest? And finally, and also very important, is how many research participants should be used? So the selection of participants is really important, and especially, again, in social or behavioral kind of research in kinesiology. So a couple terms to define. One term is the population. So in terms of sampling procedures, a population refers to the entire group or aggregate of the people that have one or more common characteristic. And a sample is a small group of the population of interest. And that sample is thought to be representative of the population. Sampling is the process or the procedure of selecting a subgroup or a sample of the population. And the sampling frame is the accessible population or collection of elements from which the sample is actually drawn. So a couple different technical terms, and you should be aware of these. Also, you should be aware of the typical steps that are involved in getting participants or volunteers for a study. So number one step would be to identify the target population. So the population is the entire group. Then what is the accessible population, that frame? Then determine a sample size, and then implement the sample plan. So how the sampling, how you get these volunteers, these research participants. So there are two main methods I want to describe in terms of sampling. And one is probability sampling. So here, probability sampling, the sampling techniques in which the probability of selecting each participant is known. So you know the probability of sampling. It utilizes random processes, but it doesn't guarantee that the sample is representative of the entire population. If you do probability sampling, you can do statistical analysis and it will estimate sampling errors, so that's a good thing. Non-probability sampling, samples are not selected at random. It's difficult to claim that the sample is representative of the population. So this is intact groups or volunteers. So probability sampling, you decide the probability of the sampling. And non-probability, it's not random. And so what is this sampling error? The sampling error is the extent to which the sample values deviate, right, are different from those that would be obtained from the entire population. Because samples are not 100% representative of a population. So when random processes are used for selecting samples, the researchers can then estimate the sampling error. So simple random sampling. With simple random sampling, every member of the population, so that's the entire group, has an equal probability of being selected into the sample. So the selection of one member of the population does not affect the chances of someone else being chosen. So each member is equal and independent. So sampling with replacement versus sampling without replacement. So like a fishbowl technique, if we put everyone's name in a bowl and we picked your name out, that would be a random sample. But if we picked your name out, we would then have to put your name back in. So so it's the same probability then. Each person then has the same probability of getting picked again. There are computer-generated sampling techniques. You can just ask Siri for random numbers. So these are examples of simple random sampling. Systematic sampling, so an alternative, is you will say, okay, I'm going to take like 1 out of every 10 people. So the researcher will choose, a sampling frame, and here K is a constant. So then you'll take every 10 number of people as the sampling frame. Another sampling technique is called cluster. And as you would expect, this is a cluster or a group. So cluster sampling or area sampling is a simple random sampling, and each sampling unit is a collection. So we want to compare SUNY Cortland compared to Syracuse University. So that's a school. Or we want to compare, the town of Cortland to the, town of Ithaca. So that's cluster sampling, and the sampling unit is the cluster. So non-probability sampling, that was the other technique that I mentioned. Here, the probability that an element will be chosen is not known. So the result being that a claim for representation of the population cannot be made. So you don't know the probability. The researcher's ability to generalize findings then are greatly limited because we don't know how representative this non-probability sampling is. But it's less expensive, it's less complicated. Convenient sampling is an example. Purposive sampling is an example. So here's this technique. When members of the sampling are purposefully selected because they possess certain traits that are critical. So if you wanted to look at, a biomechanics study of elite pole vaulters, then you would purposely select those volunteers. But that's going to be, then it's a limited generalizability because those volunteers, their pole vaulting technique or results or biomechanics may be different than SUNY Cortland pole vaulters. Convenience sampling, this refers to selecting research participants on the basis of being accessible and convenient to the researcher. So this involves volunteers. We ask you to volunteer for this study. Again, limited generalizability. An example of using, EXS to 50 students as research participants. So it's convenient to use, for example, a specific class. So something else that is important in selecting volunteers is the sample size, or how many. And regardless of the size, the crucial factor is whether or not the sample is representative of the entire population, thus how the sample is selected. So that's what we talked about. And sample size points to consider important points. What's the nature of this study, the statistical methods you're going to be using, the variability of the population, if you've got different treatment groups like a control group and experimental, and then just different practical factors. How much time will it take to analyze or test these participants? And correlational studies, descriptive studies, typically they will require more participants. Experimental studies often employ fewer research participants. And something else that is important in determining the number of participants is what is called statistical power. So power of the statistical test. So in general, the larger sample size, the more statistical power. And there's websites, and when you take statistics, you can compute the statistical power. And here's some explanation of statistical power. In general, the larger sample size, the more power of the statistics being used. And a definition of statistical power. You can think of it as sensitivity. So sensitivity that the test correctly rejects, remember, it rejects the null hypothesis when the alternative hypothesis is true. It can be thought of as the probability of accepting the alternative hypothesis when it is true. That is the ability to test an effect if the effect actually exists. So statistical power. The sample size is inversely related to the sampling error. So the larger sample size, the smaller the sampling error and the greater likelihood that the sample is representative of the population. So think about it. If there's little variability in that population, little variability in whatever you're testing, then a smaller sample size is needed. But if there's high variability, high amount of deviation, then you need a larger sample size. Also, it's the number of treatment groups. When samples are divided into smaller groups to be compared, it is important that the subgroups are adequate size. And then also practical factors. Practical factors like accessibility of these research participants, if there's costs involved, how much time will it take to test these participants. So a lot of these factors are important in determining sample size. And so some final comments. Again, descriptive and correlational research, you'll need a greater sample size. Experimental research, often a smaller size, and here you've probably seen these numbers, maybe a sample size 10 or 15 or 20. A smaller sample size is adequate. So these notes were from chapter 7, or in the new edition of our book, chapter 12, regarding sampling procedures and research participants.